Welcome to this DaVinci Resolve Fusion node breakdown. Today's node is the Replicate 3D node. So we're going to jump into Fusion, and we've got a little setup with Spotlight, Ambient Light, Camera, Emerge, our Render 3D, and I've got a little 3D particle emitter system. Nothing exciting, just something simple, because we're going to bring in the Replicate 3D node. And what the Replicate 3D node does is it replicates input geometry at positions of different vertices or particle systems, meaning we can bring in any, say, FBX or a limbic file or whatever we want to bring in and replace all of our particles with actual geometry. So first thing, we're going to go ahead and hit Shift Space and type Replicate 3D. We're going to add that node, and we're going to input it after our particle system. And this is where it needs to be. So right after whatever you want to replicate, that's where our Replicate 3D node needs to go. And if you notice, we have an input right here. And like I said, we can input whatever we want. It could be a FBX, so we could load an FBX. We can load in a limbic file, not an entire scene, but an actual file. And to make this simple, we're just going to bring in a shape. And let's go ahead and input that into our Replicate 3D. And you can see instantly it just changed our little particles to these little planes. So we can go to our Shape 3D node and we can change this to a cube. And we can still resize them if we want. But our size is going to be dependent on our particle emitter. So now if I push play, you can see we've got the little cubes emitting instead of our little blobs that we had on our emitter. Now, once I input that, you notice we've got a new input. So I can bring in another shape. And let's change this to a torus. Let's go ahead and input that into our replicate. And you notice it just switched up some of the particles to be little toruses. So let's change our torus scale here. And we're going to make them a little thinner. There we go. So now we have two different shapes replacing our particles within our particle system. Now on the replicate node itself, up top we have step. And what this step does is it kind of helps you during look dev. So if I skip this up, you can see only 4 steps of all our particles are going to be input, or only 5, or every 2, or every single one of them. So you can use this as a permanent look, or if you just want to speed things up to kind of get your look in there first and not be rendering so many particles. Under input mode, we have 2 options. We have loop and random. And what our input mode is going to do under loop, it's going to use this first shape we input and then the second shape we input. If we had a third, it would use the third input. And that means the first particle is going to spawn our first shape, the second particle our second shape, our third particle our third shape, and so on. And then it's going to loop back around. So it's going to keep spawning these particles in the order we input them. If we have it on random, it's just going to randomly generate those particles based off what we have input. And once we do select random, we can use this jitter mode up here to change that look. But let's go ahead and go back to loop. For time offset, if our shapes had animation, so let's go ahead and animate our little cube here. Let's animate our X rotation. We'll go to the end, we'll animate it, and let's animate our torus. Go to the end, Add some animation. So now if we look, everything is animated all at the same exact time according to the animation we have on our shapes coming in. But if we go to our time offset, we can offset the animation time of that incoming geometry so it's not so perfect and straight. Under alignment, this determines how our copies are going to be aligned to our original geometry. So for this one, our original emitter node. So right now it's not aligned to our particles. It's just aligned according to our shapes themselves. If we select aligned, it's going to be aligned to our particles. So now all those shapes are aligned according to the normals in the tangents of our particles. If we have TBN aligned, this is specifically for particle systems. And what the TBN means is the actual tangent, the binormal, and the normal of that particle. So if you're using particles like this, having your replicate alignment on TBN aligned will align them to the particles perfectly. Under color, we have three choices. We can use our object color, and let's go ahead and color our objects. And we'll make our little cubes blue. So for color, we're using our object color. So our color assigned to our 3D shapes. Additionally, if we have, say, a texture assigned to it or a media going into it, so we can bring this in, bring that into our little cube, it's going to use that as well. If we use combine particle color, we're going to combine the color of our particles, and right now they're this bluish. So if I change this, say, to a pink, it's going to combine those colors. Now it's not going to combine actual colors, it's going to combine colors with input material. You notice we have this input material, so it's going to combine that material with the color of the particle emitter, but ignore actual colors that we have assigned within our material on our shape. And if we have use particle color, we're strictly using our particle colors. So on our particles, if we have a color over life assigned, change this to purple, add another one, change this to a yellow. So now it'll go to our color over life, which our life is way off screen, but you can see it is actually changing. And if we go back to our replicate and combine, we can use both the texture that we input into our shape and that particle over life color that we assigned within our particle emitter. And we also have additional stuff for translation, rotation, pivot, and scale. So we can translate our shapes on the X. We can translate it on the Y. And we can translate it in the Z. In the Z. And I'm going to disconnect this so it's a little quicker. And under rotation, we can rotate them on the X. We can rotate them on the Y. And we can rotate them on the Z. And you can also change your pivot location and your scale. Under jitter, we can randomize our seed. And for this to work correctly, we need to go to random. So we can randomize our seed. We can change our jitter probability. And we can change the offset of our jitter. We can add jitter translation on the X, the Y, and the Z. our jitter rotation. We can change on the X, the Y, and the Z. And we can also change our pivot, and we can change the scale under our jitter. So that is using the replicate 3D node with a particle system, but we can also use it on an actual object. So if I remove that, and let's go ahead and grab a shape, we're going to input it. We're going to change this to a sphere, and just grab our camera and move our camera back so we can see our shape a little better. You can see it just replicated our two different shapes that we input into our replicate node onto our shape. So if we go to our replicate node, we can change that back to loop. We can change the scale of all of them so they're smaller and fitting on our little sphere a little better. Let's bring our camera back in. There we go. So you can see this is placing a geometry on every vertice of our shape. So basically everywhere there is a normal slash tangent, this is where it's placing all of our little shapes. So if we go back here and we change our time offset back to 0, now we've got all of our shapes spinning on their original animation. Additionally, we can offset it again if we want, say 2. So now you see it's all offset up here. And if we used random, we could randomize everything. We can go to our jitter and we can change our seed. And if we push play, it's showing our animation on our shapes in addition to our jitter. So that is the replicate 3D node. I will see you in the next node breakdown.